Right. So we're gonna proceed very quickly, recapping really quick. Here, an ammeter measures what? Quick. What does an ammeter represent? Main measure.
Current
Current flows through a component or it is across a component. Does current flow through or is it across?
it
Don't
flows through
Right. If it flows through, should it be hooked up in series or parallel? Series or parallel?
in series.
Right. Because when you hook something up in series, like this is an example of a series connection, right? As a series connection. You need to hook it up in series so the current could flow through. If you want the current to flow through, you should have a resistance of,
Zero.
should have ideally. Cool. A voltmeter. A voltmeter now. The symbol for a voltmeter is capital V in a circle. What does the voltmeter measure?
Voltage
Voltage. And does voltage flow through a component or is it across a component?
across.
All right. If you remember last class, I said if you want to find the voltage at a point, you measure the potential difference. So the difference between this point and the difference between this point. That's how you measure voltage. You understand?
Yeah.
Right?
Yeah.
And if you want to measure voltage, right? Do you want to measure voltage or current? Do you want any current to flow in that circuit? Or you only want to measure voltage?
You only want to measure voltage.
Right. So Aliyah, if we only want to measure voltage, do we want current to flow through? Remember, I don't want to change up your circuit too much. So if you put a voltmeter in parallel, do you want the voltmeter to use up current, or do you just want it to do its job and measure the voltage?
You just wanted to do its job.
Yeah, yeah, we don't want it to take away current. So if we don't want current to flow through, what kind of resistance it should have?
A high resistance.
Very high compared to the circuit, or ideally an infinite resistance. Awesome. If I want to combine the resistors in a series circuit, how do I do that? Let me just say I have three resistors. Justin, tell me, what's the formula to figure out the total resistance in a series circuit? Let me just say,
Um, R1 plus R2 plus R3. Well, how much have I have?
yes. Okay, so for a series, you just add in it. That's really straightforward because the resistance is one after the other. Um, is this is that a series circuit? I want to hear. Everybody unmute. Aliyah, is that a series circuit? Don't be sheep. Thelma, can I hear an Aliyah? Um, Kiara, series or parallel circuit? Okay, Justin, series.
Um,
Okay, Kiara on me.
us,
Yeah.
uh, um, series. I don't
Okay,
know.
we have
I
one for series.
think
Justify yourself. Justify why it is a series. What do we know happens in terms of current if it's a parallel? What happens to the current if you have a parallel circuit?
it diverges.
Right, splits. Will the current ever split in this circuit?
No,
Okay, that's your take on it. Aliyah, series or parallel? Justin, series or parallel?
I say series.
All right, Justin, what do you think?
Series.
Justin, can you draw the arrows showing the current, how it will flow in that circuit?
Uh, yeah, I could try.
Draw it off really fast. The current goes from negative to positive or positive to negative. Okay, look, I see the correct thing there. Nice. Yeah.
Positive to negative.
All right, so drawing off more fast.
But line's kind of better.
Small thing.
On mouse and keyboard.
Right. So I want you to tell me if at any point you see the current splitting.
No.
All right. Yeah, so everybody that said series, you all were correct. Excellent. Excellent. I can't tell you. All right. What about this circuit? How about this circuit here? Does it have any series parts?
No, sa parallel.
Based on any instances of a series,
Um, mm,
which resistors are in series?
R2 and R3.
Yeah. Justin, why are R2 and R3 in series?
Because they don't have an area for the current to diverge over there.
Split.
Split. So,
Yeah.
yeah, divergence is a good word to use, but split is a more straightforward word. So, let me ask you a question. Would the current, okay, so when you reach over here, any current will split?
Yeah.
Let me just call this I2, and let me just call this I1. Would I2 flow through R2 and R3? Asking you if I2 will flow through R2 and R3. Kiara, what do you think? Would I2 flow through R2 and R3?
Yeah.
Yeah,
Yeah.
yeah, it would. All you could see that. So if the same current going through R2 and R3 is a series circuit, over here though, the current splitting. So these two resistors are in parallel to R1. And we could do cases like that. So for a parallel circuit, what is the formula to figure out the total resistance?
1 over R, well, RP is equal to R1, R2 over R1 plus R2.
And that's the formula for two resistors though. That formula itself is only valid for two resistors in
So
parallel.
it could be 1 over RP is equal to 1 over R1 plus 1 over R2 plus 1 over R3.
Yeah, that's it. And I give you another formula here. RP is just equal to add math students, all they could use is if you flip something, what power is that? Tell me, Alia, if you flip something, what that's a what power? Kiara, you could tell me too. Whenever we
2,
indices,
it could be, it could to negative.
-1. Yeah. So this is the same formula, but a more straightforward one. Yeah. So let me look at combining resistors now. If you all want to take this on, take it on fast. So that's it for the recap. Anybody want to copy this or move ahead?
No, it's okay.
Okay, cool. I'm gonna do the question I sent on the chat really, really fast. And I want Kiera to help me with this question. Kiera and Justin. Aliyah, Aliyah, you too, because you was making me feel confident in you, and then you come in class and you say some craziness. Yeah. So kind of hesitant. I have to make sure you understand. Yeah, so Justin, I want you to explain yourself.
Oh,
I correct any homework, right? So I want you to explain how you went about doing it.
good.
You see, I explain some of how you did this.
Yeah.
So the first part is find the total resistance. I'm just gonna write find RT. RT means total resistance. First things first, first things first, I'm gonna draw in the current arrows and it'll tell me if the current arrows is correct. Yeah. Are the current arrows correct, guys? Let me know if the current arrows are correct.
Yeah.
Aliyah says yeah.
Wait, wait.
No.
Where should the current also flow in the circuit?
Um, from the 100 and the 200.
Yeah, the current will split at these points. The fancy way for it is nodes. The current will split at those nodes, right? Yeah, as you can see here. Kira, you understand everything so far?
Yeah.
So I'm asking a question, Kira. Is the current that is flowing through 250 ohms and 100 ohms the same?
You can repeat what you asked. Mommy, come in the room.
Is the current flowing through the 250 ohm resistor and the 100 ohm resistor the same? Is this current the same as this current?
No.
No, it is not. This is an example of what kind of circuit? What kind of circuit? Series or parallel?
Um, I want to say parallel.
Yeah, because current splits. This over here, where's this? Where's this, Justin?
Parallel.
Parallel. And when we find this resistance and we find this resistor and this resistor will be in what? Tamalia. When we combine this resistor, these resistors and these resistors, what we'll end up with? Resistors in parallel or series? Tamalia. So Aliyah, here we're gonna happen, right? When we add these two resistors, we effectively combining them into one, right? And then we're gonna do the same thing here.
It will be series.
Yeah, Kira, you understand why she's saying series?
Yeah.
Cool. And this is just a little introduction into combining resistors. So this is R1, so R2, R3, R4. First things first. Let's figure out the total resistance over here. Right? So I'm gonna show you all two ways you could work it out. So I want to figure out the resistance in parallel. So I'm gonna say 1 over RP is equal to 1 over 100 plus 1 over 250. Right? What is 1 over 100 plus 1 over 250? Somebody tell me fast. 1 over 100 plus 1 over 250.
In decimal form.
Fraction, if possible.
7/500.
Right, but we want to find for RP. So what we had to do, Justin, that's 1 over RP. So to find for RP, what we had to do? We have 1 over RP. We're trying to find for RP. So what did I do with 1 over
Invert,
RP to get RP?
inverted.
I inverted.
Inverted.
So you're going to invert the other side. So you're going to put 500 over 7. What is 500 over 7?
71.42.
Now that's one way you could do it. The alternative way you could have done it is like this. You could have just say RP is equal to 1 over 100 plus 1 over 250 to the power minus 1, and you get your answer instantly. So plug that into the calculator and just confirm you're getting 71.42.
But 71.42, I rounded off to 3 decimal places, so that's 71.43.
Three decimal places, you mean three significant figures?
Oh yeah, yeah.
Let me just double check that. If you round it off to three significant figures, you're supposed to get 71.4. But wait, no, you mean two decimal places. I think you mean two
Oh yeah, my
places.
bad.
Yeah, that'd be 71.43 ohms. I want you all to plug this into your calculator and show me that again getting the same thing. Justin, you have a sharp.
Yeah,
Hmm. You know how to get to the power minus one on the sharp?
yeah.
Right.
I get 500 over 7.
What you got?
500 over 7.
Yeah, I
Okay,
get the same
nice.
thing. And when you change it to decimal, it could be the same.
Cool. So what it's doing is it's flipping it for us automatically, right? So you get 71.43 ohms. Yeah. Since we did that calculation, we know what R1 and R2 is now. So I could say that R1 parallel, this is how we write it, by the way, R1 parallel to R2 is equal to 71.43 ohms. All right, cool. With that being said, Kiara, I want you to figure out R3 parallel to R4. Figure out the total resistance for me there. Which method do you prefer, Kiara? This method over here or this method?
Like the second one.
Because it's much shorter. Much. So figure out R3 parallel to R4. Figure out total resistance. So let me ask you a question, Justin. Is the 71.43 ohms different from this 100 ohms? Is the 71.43 ohms different from these two?
No.
No, because if I combine these two to one, what will I get? When I combine those two, what did I get?
The 71.43.
Correct. So the 71.43, the two of them combined. That's what I mean.
Reggie, for
Yeah.
the question, I get 127.27 ohms.
Justin or Aliyah, could you all confirm that? You're the correct answer,
Yeah.
right? And the working for that was RP. Tell me what's right. RP was equal to
RP was equal to 1 over 350 plus 1 over 200, eyes in brackets, and then the minus 1 thing outside.
to the power minus one.
To the power of minus 1, yeah. And then, well, the fraction I get was 1400 over 11, and then is 127.27.
127.27.
Yeah.
All right. And if you want to write that in notation form, you can write R3. This is how you write in notation in university, by the way. So if you want to be real bougie, you can do this. This over here just means parallel, right? That just means parallel. So R3 parallel to R4, that is equal to 127.27 ohms. So Kiara, if I can I say that this resistance is the same as this whole thing over here. Could I see that?
Yeah.
I could see that. So in other words, we're going to end up with two resistors. And these two resistors will the same current flow through it.
No.
Sure about that? Look how this circuit was set up, right? So when you combine these two, you'll get one. When you combine these two, you'll also get one. So look at the circuit now,
Oh. Oh, okay, okay.
right?
I'm
So,
mistaken.
so you understand it there?
Yeah.
So this resistor here, this was R1 parallel to R2, which we found to be 71.43. And this one was R3 parallel to R4. This was 71.43 ohms. And this one was 127.27 ohms. And if I draw the current, does the current split?
No.
No, it does not split. Remind me of the voltage. I think the voltage was 20. Could somebody confirm that for me? Aliyah was 20. Justin, what was the voltage?
Voltage was 24.
24, okay.
Yeah.
Quick question. If I increase the voltage, what will happen to my electrons in the circuit? Will the number of electrons increase, or will the speed of the electrons increase? Let me see if
The
y'all.
speed of the electrons?
Aliyah, what do you think? If I increase the voltage,
Yeah.
yeah. If you all recall, voltages are force. And the more force they have, the faster, the great. If you push somebody with more force, they will go faster. So yeah, if you apply a greater potential difference, the force acting on the electrons will be more. So the electrons move faster through the circuit, right? So Justin, now that I have these resistors are in series or parallel? Series or parallel?
Series.
Series. And just this resistance we are finding, would it be, how could we write it? This is the what resistance for the circuit. If we combine those two,
Total.
total resistance. So to write that, you would see that as RT. So RT would be equal to the R1 parallel to the R2 plus the R3 parallel to the R4, which is equal to 71.43 ohms plus 127.27 ohms. So Kiera, plug into the calculator and let me know what you're getting.
You want the fraction too, or just like the answer?
What's the answer?
198.7.
198.7?
198.7, yeah.
Yeah, that's the answer you're supposed to get. So you see that this big complicated circuit, I could write that whole thing if I wanted. I could draw that whole circuit if I wanted, as this. Just this. And here, how much resistors would it have in the circuit? After
Um,
combine all the resistors, you end up with that. So now that we have the total resistance, what can we find now? What was the second part of the question asking for?
Total current.
Total current, yes. Um, so Kira, if we want to find total current, which is IT, which formula would we use? We have voltage, we have total resistance, and we want to find total current. A formula you know have VIR in it.
V equals IR.
Wow, you're very smart.
You're
What's the
being sarcastic.
name? What's the name of it? Yeah, see, I hear new people saying it.
I said, who's saying it?
Hindu people. I mean, with a temple.
I wouldn't know.
I know that. You can probably ask Justin or Leah. I'm gonna go temple and sing. Especially Leah.
Ohm's law.
Ohm's law. Yes. Ohm. Coming back to you, Kira. Ohm's law. Ohm.
Oh, okay.
Yeah. Ohm's law. So V is equal to IR is Ohm's law. Don't forget that. You need to rename. So we are trying to find for what here? Trying to find for the Kira. We're trying to find for
The voltage.
the voltage. The voltage. The voltage.
Okay. We're not trying to find the voltage.
The voltage. We know what the voltage is. We know what else is.
The resistors, so we're finding for current.
Right, we know what the total resistance is. Say it right. We know what the total resistance is. So in part two, we have to find for IT, which is the what current. Tell me, Kira, IT, that stands for what? Think about it. We're using the total resistance and voltage. We think we find it for.
Wait, Sarah, mommy, come in the room. I was asking you something.
Oh.
Okay, ma. Okay, I'll take it.
So
Sorry.
it's okay. It's Kira. We're dealing with voltage and total current. We think we find it for then. Oh God, I just want the total current. God, I'll tell you the answer. We have the total resistance. We have the voltage. The next thing we have to find for is the total current. We could figure out the total current because we know the total resistance. So I have to make current the subject of the formula. So IT would be equal to some. Or would I be equal to? If I make I the subject of the formula, what would I be equal to?
The voltage over the resistance.
Right. Not just any resistance. What resistance we're working with here.
Total resistance.
Right. So RT. So what was my voltage?
24.
Right. The voltage was 24. And what was the total resistance?
198.7.
What's 24 over 108.7? Give me the answer to hmm, two significant figures. Yeah.
0.12.
And what would the unit for that be? Finding for total current. That'd be 0.1.
I want to say amps.
Yeah. I want you know let me go back to the original diagram. Can you identify which nodes do I have the total current? And I realized I didn't fully explain what the concept of node is. A node, you can think of it like a wire. It connects two components. So this is an example of a node because it connecting the battery to the resistors over here. This is a node as well because it connects in these components, this component, and this wire over here is also a node because it connects the battery to these resistors. Here, you understand what I said?
Yeah.
All right, so again, a node is like a wire that connects two or more components together. So over here we have a wire, and in this wire we have a current flowing. Now that wire, it connects the what, Aliyah? Aliyah, tell me, what does our wire connect? It connects the what?
The resistor. Oh my god, no, sorry.
What is this?
The battery.
The positive terminal of the battery. It connects the positive terminal of the battery to the
To the
parallel resistor over here. Right? And then this is our example of a node as well. This wire, it connects these resistors to these resistors. And then Justin, what does this wire connect?
The negative to the resistance.
R3 and R4. Nice.
Yeah.
Now, guys, I want you all to explain to me or show me at which nodes would I have the total current. Show me where the total current would be flowing. I want I have three answers. I cannot hint at it. Justin, I want you to show me the first node. Show me the wire where it would have the total current flowing through. So show me where the
Neutral
sh-
wire.
show me where the total current would be. So
Um,
show me one wire where the total current is flowing through.
um,
One wire.
yes.
That's part of a wire. You're going good. By the way, guys, wherever you see any dot, that's a connection point. That's a connection point. So wherever you see the dot, that means you're connecting one wire to that another wire. Right. So yeah, Justin, that's it. That's one answer. So over here, I would have IT. I would have IT. Kiera, see if you could show me another node where I would have IT, total current. Kiera,
Hi.
yeah. I want you to I want you to show me a piece of wire where the total current is flowing through. So the first answer was this. That was the first answer.
Um, the one that connected from resistor 3 and 4 straight to the box B.
Okay,
Yeah, that one.
cool. That's the other answer because the currents would meet back at this point. So you have the total current. Alia, they left the last one for you. Where's the other area where total current is flowing through?
Where the
So show me the last area
hold on.
where you have the total current flowing through. So this was the first answer because the current did not split. This was the second answer because the current did not split. Where's the other area you see in where the current did not split?
Here.
Oh, it didn't. Yeah. That's it. That's it. Because the total current going there. Watch. Notice that at this point the currents would meet back up,
Yeah.
and at this point the current would diverge back. So in this wire you have the total current. So that's really good, guys. That's really good. I'm gonna send the working on the chat. I'm gonna send Justin's working. Actually, I'm gonna send both Justin and Aliyah. Both of their working was good, actually. And this is the first example introducing you guys to combining resistors. So, Kiara, why do you think it was important to combine your resistors to one? What did that allow us to find for the circuit? Tell me, Kiara, by combining your
The total current.
yes, and you need the total current to find for any other thing. Let me just say, for instance, you wanted to find the current through here and here. You would need the total current. That's a little advanced. We're gonna move on to that technique just now. But yeah, you need the total current. So, Justin, why do we go ahead and combine the resistors? Why do we combine resistors in our circuit?
Because I want the current to flow at the same pace.
No.
Yeah.
Why did we find the total resistance in the circuit? What did that allow us to do?
Um, mm,
What did we find after finding the total resistance?
the total current.
Yes. So I want you all to make a note of that. If you want to find, which and you will always need to find, if you need to find total current, you need total resistance. Right? So you need the total resistance to find IT. You need it. Right? So for you to find RT, sorry, for you to find IT, you need RT. So if you are finding total current, you need RT. So Justin, why we need IT? Sorry, why we need RT? We need RT to find for what?
IT, well,
Right.
the total current.
Right. And Kira, what law are we going to use mainly in these circuits? What law are we going to use?
Also,
Swaha. Yeah. Cell Swaha and thing, you know? Yeah. Kira, you would say amen.
yeah, I guess.
Yeah.
Richie, I come back, okay?
Okay. How long? Okay.
Like 5 minutes.
5 minutes. Oh, you might miss some stuff then. That's okay. I will strategize. Make sure I don't miss too much. Right. So I presume you all copied this already. For you to find the total current, you need the total resistance. And they're going to be using Ohm's law. Right. So in the meantime, for this, wherever you did this question, I want you to put introduction to combining resistors. This is an introduction. This is the introduction to combining resistance. Combining resistors. introduction to combining resistors, right? So while we wait for Kiara to come back, you all could copy this down. Oh, and this is another formula you could use for resistors in parallel. But I wouldn't recommend it because if you have more than two resistors in parallel, you can't really use the formula. So I wouldn't really recommend that formula. But it is there if you choose to use it. All right, so you all can copy this down. Alia, which method do you think is the easiest? One, two, or three? Then find it for RP.
3.
You find three is the easiest?
Actually, no, 2 because you gain the answer instantly.
Yeah.
Like it's just a plug-in into your calculator.
Yeah, I would say two as well. And you could use two for any amount of resistors in parallel. Doesn't really matter. If you have two,
Yeah.
3, 5, so 6. All right, so copy this down. So Justin, why did we say that the 6 and 7 ohm resistor was in parallel?
Because they both divide the current, the current.
You have the correct concept, but you're saying it wrong. Will will the same current flow through the 6 ohm and the 7 ohm?
No,
No, because the current splits in. At what point?
yeah.
At what point it splits in?
Um, like A,
Yeah. I'm gonna put any circuit. Yeah. Right. So take some time and copy this down. We'll I will explain the concept and then I will give you all some questions. All right, we nearly finished with circuits. So Aliyah, after we combine the two resistors that were in parallel, how much resistors or resistor did it form?
It turned into one, so you had three resistors in the end.
Correct. And I'm asking a question. This is from last class. For a series circuit, what is the same across components? Is it the voltage or the current?
What was that?
For a series circuit, what is the same across each component? Is it the voltage or the current? For a series circuit, is the voltage the same or the current the same?
Um,
Look at the series circuit. When you look at a series circuit, what is the same throughout each component?
the voltage.
No, no, not
No.
at all. Not at all. Justin, in a series circuit, what remains the same?
Mhm. Um,
I want you to look at this. What's the same through all components?
The current.
current.
The current, as I wanted to hear.
Oh
Aliyah,
no,
let,
I was watching the other one.
Aliyah, let me explain something, right? Why you shocked me just now. Check it out. What's your formula for voltage again? V
V
is
is
equal
equal to
to,
IR.
okay. So we established the same current flowing through, right? Right?
Yeah.
Okay. So are the resistance the same?
Yeah. No.
No. So if I want to find the voltage here, the voltage will be the current by the resistance. But this have a different resistance from this. So until you get different voltages,
Yeah.
let me just say the current was 1, right? So let me just say the current is 1 amp. The total current is 1 amp. What would the voltage at R1 be? What would the voltage over there be?
Um, the current by
V is equal to
IR.
the
So it could
resistance.
be 8.
Yeah, so the voltage will be 8. Let me look at the second one. Any same current flowing through this?
Yeah.
Okay. So, well, how would
It
I
could
calculate?
be it could be 1 by 3.28 and you'll get 3.28.
So is the voltage the same?
No.
No. Last class we had a big discussion on it. How is your house wired? If I ask you how your house wired, is your house wired in parallel or series?
Um,
Do you want appliances in your house to be getting different voltages?
no. So Siri.
Series? Okay. What is the same in a series circuit, the voltage or the current? In a series circuit, what is the same, the voltage or the current?
The current.
Right. The voltages will be different.
Yeah.
You don't want that. You need the same voltage in your house. You need the same voltage for your air conditioner, for your fridge, when you're charging your phone. And another thing, in a series circuit, if I cut the wire over here, let me just say I feel mischievous and I cut the wire over here. What happens to the circuit?
The current wouldn't flow.
Yeah, so I'll create a what kind of circuit? What I call that? I have two
Ah,
types of circuits, open and close.
open
Right.
circuit.
But let me just say that I cut this wire over here. Will the current still have a path to flow?
Yeah.
Yeah, it will flow through this. So how is your house wired? In series or
Parallel.
parallel? Parallel. Parallel. What is the same for parallel circuits?
The voltage.
The voltage. The current would
Yes.
change because what happens in parallel circuits?
Um, it is split.
Yeah, the split. Exactly. So,
Okay, yeah, that makes sense.
yeah, think about it. So when you all have that copy down, let me know.
Okay.
Kira, are you there?
Hi.
Yes, Kira. Hmm. Things seem stressful on your end.
I guess.
Yeah. It seemed like you're under duress. Perchance, are you okay?
Yeah, I know, Mom.
All right. So our other copy is on. In the previous example, that would have been an introduction to combining resistors. So I gave you all a question without telling you knowing where you had to combine resistors. And we formally started it here. So since you all did a question on it already, I could probably give you all a question to test. See if you know it. Actually, I'll do voltage divider and current divider one time before we do questions. Okay. So let me know when you have that copy done.
Did you ever finish?
You finished copying down everything?
Yeah, and I didn't all come back. I was here.
All right. So everybody have that copy done, right? Justin.
No, I almost done.
Okay. Okay, yeah, Justin, you can use the washroom fast. Kira, the next part of this will get a little more complicated. So I need to make sure you understand everything. What's the easiest way to recognize a parallel circuit? What happens in a parallel circuit? Do you
It is diverged the current.
say that again?
The current does diverge.
Yeah, the split. That's the easiest way to tell. So for a parallel circuit, we think remains the same. The current through each component or the voltage across each component.
The voltage across.
Yeah. You can think of it like distance. Any distance between this point and this point is the same. Think about
Yeah.
so for a parallel circuit, the current through each component is different. You need to know that desperately. You need to know that. But do you think? Wait, did I just not say that the current has to be the same or the voltage has to be the same?
The voltage.
Okay, good. Kind of tired. So my brain kind of conking off on my. Whew. So for a parallel circuit, the voltage has to be the same. The current will change because the current is splitting. In a series circuit, what is the same, the voltage or the current?
The current.
Yeah, the current is the same because the current does not divide. What changes though?
The voltage,
Yeah, because what's the formula for voltage?
V equals IR.
Is the current changing? For a series circuit, is the current changing?
No.
No. But is the resistance changing?
Yeah.
And so when you multiply, we get different results. Like let me just say it's 8. 1 by 8 is 8. 1 by 3.28 is 3.28. So different voltages. Simple way to think. Easiest way to think about it. You understand?
Yeah.
Yes. So I just given Aliyah some time to copy this on. Aliyah, as soon as you have that copy down, let me know.
Okay, I just write in the last equation.
Okay. Wait, let me just change something real quick. Even it is series resistance, but it would really call it RT because what we really found there is total resistance. Even though it was in a series manner, it's really RT. It really found for there is total resistance. Yes, so Justin, make sure you have this copy down.
Yeah, I have a copy of
I'm just looking, send a picture in the chat. Because finally I taking a long time to copy this down. Is either
Um,
is either Alia do it real scrappy or Alia just do it real neat.
oh my god, you wanna see my drawing?
Yes, let me see it.
Send it on the group chat or
On your group chat. Okay, damn. Justin, one more thing. Just change the RS to RT. The reason I'm saying that is because even though it is a series resistance, it is. What we really found is total resistance in the circuit. Another thing, please put your current in the circuit so you can see why we saying it's a parallel. So Justin, the easiest way we could tell that two components are in a parallel network is if the current is what? How do we know that you have a parallel circuit when the current is doing what?
being divided.
Exactly. So the next thing we're going to look at is voltage divider and current dividers. What kind of circuit you think will have a voltage divider? Series or parallel? What kind of circuit you think would exhibit voltage dividing? Sorry, voltage division. Kara, you tell me, what kind of circuit will have voltage division? Series or parallel?
Parallel.
Hmm. Voltage division is when the voltage changing, you know. That's when the voltage is being split across resistors.
Oh, series.
Series. And for current divider, parallel or series, Justin? Justin, when we looking at current divider circuits, will that be Parallel or series?
Parallel.
Yeah, because in parallel circuits, the current divides. All right, nice. Wait, I want you all to look away for a second. I'll just give you all some questions. Oh, easy questions, really easy questions, nothing hard at all. Yeah, I want you all. Hey, what I want you all to do, I want you all to find the total resistance, and I want you all to draw the diagram. Draw the diagram with the total resistance. So with one resistor. So do that for me. So I want you all to figure out the total resistance of that circuit. Find the total resistance. Yeah. So Kiara, you getting through?
Yeah.
Okay, nice. Oh yeah, you getting through?
Yeah, I kind of drawing the diagram.
All right. Question. If I were to add, if I were to give you a voltage, would you be able to find the total current?
Yeah.
Okay. Give me ideas. Nice. Justin. Justin, I'm gonna figure through.
Yeah, trying something.
Trying something.
Yeah.
I mean, you're trying
No.
something.
Well, I get you the total resistance, but trying the diagram.
Okay.
Wait, you want one resistor alone with total, or you want like three with to make up the total?
So what I want is, I want you all to find total resistance and draw a
Right.
circuit with only one resistor in it. Because if you have the total resistance, you have the resistance for all the resistors combined. So I just want a circuit with a power source and a resistor. One power source, which is the battery, and one resistor, which is the total resistance. Yeah.
Mm, yeah. This might be wrong, but that's the answer.
So I catch you real good. Hmm. Not real wrong. That's very wrong. So Justin, you're saying that everything here is series? That's what you're saying?
Mm.
Oh, wait, explain yourself. Explain yourself. Explain how you do that wicked.
Uh, I just add up all the resistors.
Aliyah, tell Justin what's wrong with that. He literally just add up all the resistors. What's wrong with that?
Um,
Don't tell me you do the same thing.
no, I was gonna follow the formula to find for more than two resistors.
Mm-hmm. So let me ask you a question. In this circuit, are all the resistors in series or are all of them in parallel and have a combination?
A combination.
Yes. Justin, which resistors are in series and which resistors are in parallel? See if you can tell me that. Let me share back on screen. Right, so this is R1. Remind me, how can you tell if something, if a resistor is in series versus if it's in parallel? How can you tell?
Um, Parallel, they're being split up on series,
Wait,
going in one,
it splits up. What is being split up?
the current flow.
Okay, cool. So I want you to show me where in the circuit I have total current. Show me the places where I have the total current. Places where I have total current, that would be what? Series or parallel? If I have if I have the total current flowing through it, would that be series or parallel?
Series.
Okay, cool. So you know that. So what resistors automatically in series and
Um, Resistor one,
right?
resistor 5.
Okay, cool. Cool. So when you have resistors in series, what's the formula it is used to add them, to combine them?
Um, well, it's just R1 plus R2.
Cool. Now show me the part of the circuit where you see in current being divided. At what point in the circuit is current being divided?
Um, then
Yeah. So if you're seeing current being divided, what kind of circuit is that? Series or parallel?
parallel.
And we combine parallel resistors in the same way we combine series resistors.
No.
We do not. What's the formula we use?
Um, RP equals to 1 over R1 plus 1 over R2 plus 1 over R3 to the power minus 1.
Yeah.
See what I'm making a mistake.
So the thing with this question is you you had to realize where it's in series and where it's in parallel, and you had to use the appropriate formulas. If you want, work it in parts. You don't have to work it in one shot. Work it in parts. Kira, are you getting through?
I thought I was going good, and then I realized I do something wrong, so I'm gonna start over.
What do you think you do wrong? Tell me.
Um, when I was adding up the resistors, I add up the wrong ones.
Which resistance you added?
Add up one of them.
Oh, oh. But
Yeah, I know what to do. I know what to do.
okay. I feel Ali, I might have the correct answer, you know. I think so. Alia, what do you think?
Probably not.
Yes, I'll give it Alia seven more minutes.
So we just find in the resistance, right? The total resistance.
Mhm.
Okay.
Rajiv, I have a question.
Let me hear.
In like a past paper, well, past papers, right?
Mhm.
Like how much marks like a question like this would be worth
5 marks,
at most?
5 to 8.
Okay.
The whole question will probably be 15. But the circuit pass alone is like 5 to 8. The calculations will make up the other marks. Wait, okay. Wait, Justin, a little confused by something, right? A little confused by something. You gotta explain this something. How in the world you get 8 ohms and 3 ohms? Where did the 8 and the 3 come from? A little confused about that.
Um,
From where did the 8 and the 3 come from?
I divided up to make up the 11.
Why do that?
Uh, um,
You see any 8 and 3 in that circuit?
no,
No. What was the resistance? What was your resistance in the circuit? What was the resistance in the circuit?
1 and 10.
Exactly. So you're not supposed to touch that. Not at all. Not.
Oh,
Why are you interfering with that for? I don't know what I was thinking, but yeah, the resistance series is correct.
my
The
working correct?
parallel. I'm gonna check that. What just really confuses. Why would you change it to 8 and 3? I didn't even. I, I'm not judging you or anything. It's just like pure curiosity. Like I just really confused. Like I'm curious. Hmm. Yes, it got up to 11, but changing the you're changing the parts in the circuit. Hmm. That's like if you replace. That's like in a cake. If you replace the sprinkles with tomatoes, it wouldn't do that.
Indeed.
It wouldn't do that. Yeah, you found the correct value for RP. So here what? But when you find the resistor for series, write it as RS. So R small s, and for parallel, R capital R small p. Right?
Yeah.
So you have the correct value for series when you add up the series, and you have the correct value for the parallel. You just need to combine them now. So what kind of circuit did it form eventually? What kind of circuit that look like? Change the eight,
Series circuit.
change the 8 and the 3 back to 1 and 10. What kind of
Right.
what kind of circuit you looking at there now?
Series.
Series. I want you to draw the current from a start. Again, you have it at drawing your current. I know this is not drawing your current. Draw your current. Draw your current so you can see if it's split at anywhere.
Okay. No,
Hmm?
no,
What do you mean by no?
it didn't split.
It didn't split. So if it didn't split, what kind of circuit you have?
Series.
Exactly. And if you want to combine resistors in a series circuit, how you do that?
Repeat that.
If you have a series circuit, how do you combine resistors?
A series circuit and you want to combine resistance.
Yeah. How do you combine the resistors to find the total resistance? You know how to do it.
Um, in no, I can't. What? No, no, in both.
Hear what I'm saying, right? It's a series. You have resistors in series. How do you combine the resistors?
Add them together.
Yeah, that's it. That's it.
Oh, overthinking.
Yeah. Mhm.
Rocky say he may bring us for coursework. We are coursework next week again.
Oh, okay, okay.
Either coursework or another term. And the term is be week or the week before school close.
Well, I will do current divider and voltage divider tonight then.
Yeah.
So I'm waiting for somebody to send me the final answer. Aliyah has been taking a long time.
Richie,
Kiera.
I done, but my notes are all scrappy right now because I had to rewrite it after. But I will send you it, and you had to try and understand it, okay?
Okay.
Okay, I'm gonna send you my answer now.
Yeah.
I know it's wrong, but whatever. Wait, hold on.
Kiera, the
I
correct
think
answer. Yeah, Kiera, that's correct. Big up yourself. Big up yourself. Let's go. Aliyah, I don't know what to do. Um, I feel like you're overcomplicating your life. Usually use this formula and it will make it much more simple for you. Use this one. This formula here, you could use with any amount of resistors. You just add anything. You see, Aliyah, if you use that formula, right, you know how to take the 0.40 and then raise it to the power minus 1. Any food, because you're flipping it. You're flipping it.
yeah.
So just do this formula and go save your time. So work it back. Justin, you had the answer, you just had to add it and combine it. So summer we have. Yeah, Justin, let me see what you have after you combine it.
Oh my god. I don't know why it's sounding like that.
What?
I don't know why it keeps sounding like that.
Solia, yeah, that's correct, but I don't like how you're writing the working. It's I don't know. I don't like it. Let me work on it. Right? Let me work on it. So let me identify the resistors in series. So which resistors are in series? Just by looking at the total current. Which resistors you have the total current flowing through? Talmalia. So which resistors? You have the
1 and 10.
right. So we're gonna say R1 plus R5, and that'll be equal to 10 plus 1. That'll be 11 ohms. Right? And we have the parallel aspect to look at. Now I would write RP. So RP will be equal to 1 over 5 plus 1 over 9 plus 1 over 2 to the power minus 1, and you get your answer instantly. You gotta beat up your head about nothing. Get the answer one time. Tell me, you're confused with our method? Because that's the
No,
easiest method. That's the
yeah.
easiest method. You'll get the answer one time. So,
No, I'm not confused.
oh. So plug this into the calculator and tell me what you get.
90 over 73.
Right? What is our decimal? Two decimal places.
1.23.
1.23 ohms. Right? So what we're gonna do now, I'm gonna draw back the circuit real quick. Analia, what do we know that the combined resistance of the parallel circuit here is? The resistors in parallel. What's the combined resistance? What's the combined resistance for the resistors in parallel?
1.23.
Right. So essentially end up with a circuit that looking like this. And in this circuit, is the current dividing? Salmalia, see the current dividing?
Yeah.
We see not current dividing. Hmm.
No.
Watch.
No, it's flowing.
In one direction.
Mm-hmm.
The reason for that is because we combined all of these resistors into one resistor.
Oh.
So if I want to find the total resistance, RT, the total resistance is just is R1 plus R2 parallel to R3 parallel to R4 plus R5. You know how to write all of this? Well, I just write it because it's the proper way to do it. So Aliyah, and we already know what R1 plus R5 is,
Yeah.
right? So we know that is 11. And what is R2 parallel to R3 plus parallel to R4?
R2 parallel to
What do we
R.
calculate that to be? The combined resistance for the
That could
resistors.
be 1.23 ohms.
Right. Now, how I would advise you all to do this question, I would advise you all to combine your resistors in parallel first and then put it into the circuit. You see this part here with the series? You don't have to do it. This is optional. How I would advise you all to do it is find the resistors in parallel first, replace it in the circuit, and then find the answer. So I would just say 1 plus 1.23 plus 10, and the answer would be, did you all get 12.23 ohms?
Yeah.
Right. So you know how to find the series, but if you could see it, if you can see that's fine. That's fine. So from this point over here, you could have just add the 11 and the 1.23 and get your answer. Nothing is wrong with that. Or you could find the parallel first, replace it in the circuit, and then just add all in series. Nothing is wrong with that either. Both are correct. Right? So make sure you have this copied down. So guys, typically we combine the resistors in parallel first. That's what we do. So Justin, you're there.
Yeah.
Anytime you have current being divided, what kind of circuit is that? Series or parallel?
parallel.
And what you want to do is you want to immediately combine those. You want to immediately combine them into one resistor. Immediately. And then you could draw back the circuit. But instead of putting all them resistors, you just put one. So Justin, instead of writing these three resistors, instead you just write 1.23.
Yeah.
Yeah, you just do that. Cool. All right, so now look, guys. I want you all to try this question. So you all can do it however you want once you arrive at the same answer. But try to make your life simple. Hear my advice again, guys. Wherever you see a parallel, wherever you see parallel resistors, combine them one time and replace it. Because Kiera, and when we combine the parallel, and we just get one resistor, and we just get one resistor,
Yeah,
and that's make the circuit series or parallel.
series.
And series really easy. We just add that. So figure out question two. Give me another 5 minutes. 5 minutes for that.
Okay, well, I wouldn't draw.
Aliyah is someone vex.
No,
Yes. I don't mean anything bad, eh? I just say that that's the easiest way to do it. That's the
no,
easiest.
I understand.
Yeah.
Because it kind of confusing if you do it the other way, like it more complicated.
Yeah, because think about it. When you reach your point and you gotta flip it. But if you get a
Yeah,
decimal, you can't exactly flip it. You gotta raise it to the power minus one. So just do this one time. So you go flip one time.
yeah.
If you do that in the exam, you wouldn't get it wrong. You just have a higher chance of doing the wrong thing. Remember the first time you said made you get a wrong answer.
Mm-hmm.
Yeah. So I don't mean anything personal. Don't get vexed with man thing. Don't
No, I'm
come
not vexed.
don't come up center. Don't come up around with and shoot man thing. Oh, hmm. Oh, Ali, I guess who I see?
Who?
I see Chloe.
Chloe?
Nice number, girl.
Oh my God, for real?
So here is it. For one of my projects, we have to measure a table and do up a 3D diagram for it. And a plan and a sectional view. So lunchtime, I went in the library with my measuring tape, and she was sitting down right on the couch, and I was there on the ground and thing measuring the table, and she was like, "What you doing?" And I was like, "This is for our project." Yeah. And then this guy come up to she and ask
Oh
she
my
if
God.
this guy come up to she and ask she if she's nice number girl. And she was like, no, she's not nice number girl.
Oh my God.
Apparently she knew it. Yeah.
That's so cool.
I have a lot of TikTok people on you in UV. A lot. I see them all the time.
Really.
Yeah. Right? So continue. Or we could figure this out. Yeah, any answers? Kira, see something. Kira?
It wrong?
I don't know.
Mm, what wrong?
You really want me to tell you?
Wait. Let me rewatch everything.
You did nothing wrong. You did get the correct answer.
Oh, thank you.
You're welcome. One thing though, the top part, I see you have RT. That's not RT, eh? That's RP. It's RP.
I keep mixing it up. My bad.
And the second one, while it is series resistance, you find it for the total resistance. So, right, RT. Now the good thing I
So the
would,
only thing is I'm mixing up these.
I don't think,
The only thing is I'm mixing up these little symbols.
yeah,
Wouldn't they have marks fits? Because it basically mean I'm doing the wrong thing.
you're not doing the wrong thing. You just, your terminology is not perfectly there.
Okay.
So, you have to understand what you're doing perfectly. So, the first one, you wasn't finding for RT. That's not the total resistance. That's RP as your resistance parallel. The second one, that's not RS. Well, yeah, is resistance in series, but right RP. If you want to write RS, you can say 17 plus 10. Um, Aliyah, let me see what we have here. Yeah, Aliyah, I'll take that. That's correct. Nice. You see how easy that was to
Yeah.
follow? You
You
didn't
like
even
my
have to
drawing?
write the fraction.
You like my drawing?
Yeah. So, guys, I want to draw that circuit with one resistor in it now. Do that. I didn't get an answer from Justin though, so that's all worrying. Justin, what going on?
I find he extra
Nah,
quiet.
join the circuit one time.
Find you extremely quiet. It's like
Yeah.
insane.
Nah, join the circuit one time.
Okay.
Well, I tried.
What time you finishing class? 1:30?
Yeah, half fast.
Okay.
I'm shocked, sweet. I forget to write in the current. Join the current.
So, Kiara, it seems like you understand this circuit thing pretty well. What do you say? Hey, Kiara. Okay, Kiara. I'm not hearing Kiara. Aliyah, you seem like you understand it too, but you do some weird things sometimes.
Yeah, I know.
And Justin, you too. I don't know why you do that 8 and then 3. It's still confusing, man. I'm still confused. Hmm. Don't add don't add vegetables on our cake. You don't want to change how the cake tastes. The same way you don't want to change how the circuit working. Yeah. Just be careful of that. Justin, I'm not being mean or anything. I'm not judging you. I just don't take no horrors. I just curious.
No, 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 no.
Oh, let's see how Liam Payne died.
Oh yeah, that was so sad.
I don't really care, but I find it's real weird though. Like he just fall off a building. Like what?
He
How
jumped
did
off the building.
so he
It
committed
was
suicide then?
yeah,
That make more sense.
yeah.
Sad.
Because I
That's sad.
think his girlfriend had leave. His girlfriend had leave a few days before
Hmm.
that happened.
People are Ravi or
Oh my god.
or a Prakash.
For real. He was in Argentina.
That's crazy, bro. Okay, guys. So everybody got the question correct. Now, the final question is I want you all to draw. Here, I want you to do for my listen carefully. I want you to draw a circuit with one resistor in it. One resistor.
As
Not three. One. One resistor. Just one.
what?
Just one. Let me see how much all you can figure out what I'm asking. Just one.
Minecraft?
That's not what I'm asking. Asking for one resistor. By the way, Justin, yeah, your calculation's correct. So the
Which
last
diagram
one,
wrong?
right? RT. RT. What
Yeah.
um what I want is I want a diagram with one resistor in it alone. Not three, just one. Just one.
Oh, wait, wait, no. Yeah, I think I know what to do.
Okay.
I think.
Maybe I overthinking it.
It's real simple,
Just listen.
Extremely simple.
Okay.
Like, oh my God. I trust. Yes. Kira, are you there?
Hi.
Yeah, Kira, are you to draw the circuit for me? Draw draw an equivalent circuit, but instead of having what four resistors, just for one resistor. Yeah. See if you understand what I mean. So instead of your circuit having these four resistors, just draw a circuit with one resistor. That would mean the same thing as all of this. If you know what I mean, wink wink. Yeah.
Minecraft.
Yeah, answer is nine. Let me see. Oh, you asked me if you was correct. One thing, forgetting the units. Please put your units. The units. Yeah, correct. That's what I mean. Yeah, that is what I mean. You
Wait,
figured it.
diagram correct?
Yeah. And
Yeah.
if you had a voltage, you could use the voltage to find for what? The voltage and the total resistance to find for what?
You're correct.
The watt current. Not just any current, the watt current.
What do you mean?
If I have the total resistance, I could find the watts. Total
The current
resistance is used to find the
circuit?
huh?
The current in the circuit?
Total current in the circuit.
The total. Okay, well, yeah. You see my diagram?
Let's see the diagram. Wait, somebody wrong. Wait, Justin, I think you did something wrong, you know. I think you did something wrong. Yeah, you do something wrong, Justin. Justin, where's 24 over 25? What is 24 over 25? Tell me.
Huh?
So, I want you to explain to me something. When you was finding for your parallel resistance, how did you go about doing that? Walk me through the steps.
Um, 1 over 24 plus 1 over 1 in brackets, um, 5 minus 1,
Okay, right? I'm gonna get,
24 over 25.
which is
0.96.
to get the answer, you get that. What I mean, you flip it. But why you flip it though? Hmm. You flip it because yeah, custom flipping it. But here it is.
Yeah,
With our formula, it is do all the work for you. All. So that's why I say that formula I really easy to use. You just plug it in and you get your
we'll
answer.
leave it at leave it at 0.96.
Yeah, yeah, because that's literally the formula. So when you get it 24 over
Okay.
25, that is the answer. You don't have to do anything. So
My
fix up it.
diagram still correct. I just had to change the value.
Yeah, yeah, you just have to change the values. So I want you to calculate the total resistance and just fix it up.
27.96.
Yeah, that's it. Kira,
Okay.
I think you sent me the correct thing, and you delete it.
Because
Hmm.
I thought it was wrong.
Send it back now. Send it back. Send it back.
I don't want to talk to you.
Hello, Eden. Good night.
And you coming to talk to him now, or you want to talk to him after? You want to talk to him now, or you want to talk to him after? He said after class.
Was he go and tell me something bad or he want to catch up? And did I do something wrong? Tell him, yeah, we will talk after class.
Oh, he wanted to help him with that graph.
Oh, I well tired, but I'll see. Yeah, so do up the circuit diagram for this. Yeah, that's correct, Kira. I don't know why I was so worried, That's correct. That's literally it. Yeah, that's it. So nice. I just waiting on Justin to fix up his answer and send it to me. Yeah, that's correct, Justin. So nice. Next class, we finishing up circuits, and we're gonna move on to next class. We're gonna speed there, and we're gonna look at VI characteristics, finding resistance of an unknown resistor. Yeah, we're gonna do plenty work next class. We have a lot of work to do next class. A lot, right? So yeah, guys. Hope all you have a blessed night. Thank you for making it to class today, guys. Have a good night. Later.